You might think paper comes from trees getting chopped up in giant machines. But 1,000 years ago in Song Dynasty China, entire workshops were turning bark into writing sheets, using nothing but human hands and ancient techniques. Let me tell you something fascinating about the year 1100. While Europe was still scratching words onto animal skins and wax tablets, Chinese papermakers had perfected a process so efficient they could produce hundreds of sheets per day using methods that would make modern environmentalists weep with joy. Picture this. You walk into a papermaking yard in Song, China, and the first thing that hits you isn't the sight, it's the smell. Steam rising from massive vats, the earthy scent of mulberry bark soaking in pools, and that distinctive alkaline tang that means serious chemistry is happening without a single test tube in sight. These weren't just craftsmen. They were industrial chemists who figured out how to break down plant fibers into smooth writing surfaces centuries before anyone knew what molecules were. The numbers alone will blow your mind. A single papermaking workshop could process enough mulberry bark in one day to create writing material for an entire government office. We're talking about production rates that rival some modern small-scale operations, except these guys were doing it with wooden tools and muscle power. But here's what makes this story really incredible. Every single step of their process was designed to solve problems that modern papermakers still deal with today. Before we dive into the nitty-gritty of how they pulled off this ancient miracle, make sure to hit that subscribe button and give this video a thumbs up. I want to hear what blows your mind most about this 1,000-year-old technology, so drop a comment about which part of the papermaking process surprises you the most. Trust me, by the end of this series, you'll never look at a piece of paper the same way again. Now, let's start where every great paper story begins, with trees that most people would completely ignore. Mulberry trees weren't chosen for papermaking because they looked pretty or grew fast. These particular trees had bark with something special hidden inside, incredibly long, strong fibers that could be transformed into smooth writing surfaces. But getting those fibers out was like performing surgery on a tree, except the surgery had to be perfect, or months of work would be wasted. The process started with what papermakers called the harvest dance. Workers would select mulberry branches at exactly the right time of year. Too early, and the bark wouldn't strip properly. Too late, and the fibers would be too tough to work with. They'd score the bark in careful spirals, then steam the branches over massive cauldrons until the outer bark started to loosen. This wasn't gentle work. It required timing that would make a Swiss watchmaker jealous. Here's where things get interesting and kind of gross. Once the bark was steamed, workers had to strip it off in long continuous pieces while it was still hot and slippery. Imagine trying to peel an orange in one piece, except the orange is the size of a baseball bat. It's burning hot, and if you tear it, you've just ruined hours of preparation. The skilled bark strippers could remove pieces up to 6 feet long without a single break, a technique that took years to master and probably left their hands looking like they'd arm wrestled with sandpaper. But raw bark strips were just the beginning of this ancient transformation. The real magic happened in what looked like the world's first industrial spa treatment for plant matter. Those freshly stripped bark pieces got tossed into soaking pools where they'd sit for days, slowly breaking down in a process called retting. Think of it as controlled decomposition. The papermakers were basically convincing the plant fibers to separate themselves through careful neglect. The soaking pools weren't just holes filled with water either. These craftsmen had figured out the perfect balance of moisture, temperature, and time to break down the bark without destroying the precious fibers inside. Too much soaking and you'd end up with plant mush. Too little and the fibers would stay locked together tighter than a miser's purse strings. Some workshops had soaking schedules so precise they could tell you exactly which pool contained bark that had been soaking for 3 days, 5 days, or a full week, just by looking at the color of the water. Once the bark had softened to the right consistency, it was time for the cooking phase. And this is where Song Dynasty papermakers proved they were basically medieval chemists. They'd transfer the soaked bark into massive cooking vats filled with an alkaline solution made from wood ash and water. This wasn't random guesswork. They'd discovered that certain types of ash created exactly the right chemical environment to dissolve the lignin holding plant fibers together. The cooking process itself was like watching the world's most boring yet crucial stew. Workers would maintain specific temperatures for hours, stirring constantly with long wooden paddles to ensure even cooking. The alkaline bath would slowly eat away at everything except the cellulose fibers, nature's own way of separating the useful parts from the stuff that would make terrible paper. Getting this step wrong meant starting over from scratch, which explains why master papermakers guarded their cooking recipes more carefully than state secrets. What made this alkaline cooking so brilliant was that it solved a problem modern papermakers still struggle with: how to get strong, flexible fibers without using harsh chemicals that damage the environment. These ancient craftsmen had figured out that wood ash, something they had plenty of, could do the job perfectly when used in the right proportions. The whole process was sustainable centuries before anyone knew what that word meant. After hours of cooking, the real test came during the rinse phase. Workers would carefully lift the cook bark from the vats and wash it in clean water until every trace of the alkaline solution was gone. This wasn't a quick splash and done operation. It required multiple rinse cycles in fresh water, with workers checking the bark constantly to make sure the fibers were clean but not damaged. One careless rinse could turn perfect papermaking material into expensive compost. The rinsed bark at this stage looked nothing like the original tree bark or the paper it would eventually become. Instead, it resembled wet cotton that had been through a washing machine accident, stringy, pale, and surprisingly delicate despite all the processing it had endured. But those innocent-looking fibers contained everything needed to create writing surfaces that would preserve Chinese literature and government records for centuries. This is where the story gets really impressive, because what came next required the kind of teamwork that would make modern assembly lines look disorganized. The clean, cooked bark fibers were about to undergo a transformation that turned individual plant strands into the smooth, uniform material we call paper. But first, they had to be beaten into submission, literally. The beating process was where papermaking became a full-contact sport. Teams of workers armed with wooden mallets would spend hours pounding the wet fibers against stone surfaces, gradually breaking them down into smaller and smaller pieces. This wasn't random violence against plant matter. It was carefully controlled destruction designed to create the perfect fiber length for papermaking. Too much beating, and the fibers became too short to bond properly. Too little, and the finished paper would be rough and weak. Different papermaking shops developed their own beating rhythms, with teams working in synchronized patterns that looked more like a dance than manufacturing. The sound of multiple mallets hitting wet fibers created a distinctive rhythm that could be heard throughout the workshop, a percussion section for the industrial symphony of ancient papermaking. Some master papermakers claimed they could tell exactly when the beating was complete just by listening to how the mallet sounded against the pulp. But all this careful preparation was just setting the stage for the real magic. The real wizardry happened when those beaten fibers met water in what looked like the world's largest mixing bowl. The vat preparation was where papermaking transformed from craft to pure science, and these ancient masters had figured out ratios that would make modern chemists jealous. They'd fill massive wooden vats with clean water, then add the beaten pulp in precise amounts. Too much fiber and the sheets would be thick as cardboard. Too little and you'd end up with paper so thin it would tear if you looked at it wrong. But here's the secret ingredient that separated amateur papermakers from the pros: plant mucilage. Sounds gross, right? It's basically plant slime extracted from roots and bark. But this gooey stuff was liquid gold in the papermaking world. A few drops of the right mucilage would make fibers float evenly throughout the water instead of clumping together like wet cotton balls at a pool party. The best papermakers knew exactly which plants produced the stickiest, most effective mucilage, knowledge passed down through generations like family recipes. Getting the vat mixture perfect required the kind of precision that would make a pharmacist nervous. The water temperature had to be just right. Too hot and the fibers would cook. Too cold and they wouldn't distribute properly. The consistency needed to feel exactly right when you stirred it with a wooden paddle. Master paper makers could tell if a vat was ready just by watching how the pulp moved through the water. It was like reading tea leaves, except the future they were predicting was whether the next 100 sheets would be masterpieces or expensive mistakes. Now comes the part that separates the legends from the wannabes, the vat man's moment of truth. Armed with a mold, basically a wooden frame with a mesh bottom, the vat man would dip into the pulp mixture with movements so smooth they looked like dance choreography. This wasn't a casual scoop and dump operation. The angle had to be perfect, the speed exactly right, and the timing flawless. One wrong move and you'd either get a sheet full of holes or a blob of pulp that looked like it had been sneezed onto the mold. The real artistry came in the shake. After lifting the mold from the vat man would give it a specific shake pattern that locked the fibers together like puzzle pieces finding their perfect fit. This shake wasn't random jiggling. It was a carefully practiced motion that distributed the fibers evenly across the entire surface while encouraging them to bond with each other. Different paper makers had signature shake patterns, and you could often tell which workshop had made a sheet just by looking at the fiber distribution. What made this even more impressive was the speed these guys could work at. A skilled vat man could form a new sheet every 30 seconds, moving with the kind of rhythm that would make modern factory workers weep with envy. They'd dip, lift, shake, and pass the wet sheet to the next worker in one fluid motion, then immediately start on the next sheet. Hour after hour, day after day, maintaining that perfect consistency that meant every sheet would dry to the same thickness and strength. The handoff to the coucher was where teamwork became crucial. The coucher, basically the guy responsible for stacking wet sheets, had to receive each delicate, water-soaked sheet and transfer it onto a growing pile without tearing, wrinkling, or otherwise destroying hours of careful work. Between each sheet went a piece of felt, creating a sandwich pattern that would make the pressing stage actually work. Getting the felt placement wrong meant sheets would stick together permanently, turning expensive paper into expensive papier-mâché. Watching a skilled vat man and coucher work together was like observing a perfectly choreographed ballet performed by people covered in plant pulp. They'd develop an almost telepathic communication. The vat man would know exactly when the coucher was ready for the next sheet, and the coucher could predict when each sheet was coming without even looking up. Some teams worked so well together that they could produce over 200 sheets in a single day without a single mistake. But stacking wet sheets was just the beginning of turning pulp into paper. The press crew had the job that required both strength and finesse, squeezing water out of the stack without crushing the delicate fibers inside. The pressing operation used massive wooden presses that applied tons of pressure gradually, like slowly tightening a giant vise made of tree trunks. Too fast and the sheets would be squeezed into pulp pancakes. Too slow and the water would never come out properly. The pressing happened in stages, each one designed to remove more water while maintaining the paper's structure. First came the gentle squeeze, just enough pressure to start water flowing out of the stack. Then the serious pressing began, with workers adding weight gradually until water streamed from the felt like tiny waterfalls. The sound of water dripping from a properly pressed stack became the soundtrack of successful papermaking, a rhythmic patter that meant everything was going according to plan. Between pressing stages, workers would carefully peel apart the sheets and replace the wet felts with dry ones. This was delicate surgery performed on wet paper. One wrong move and hours of work would literally fall apart in your hands. The best sheet handlers could separate paper so thin you could see through it without leaving so much as a fingerprint. They developed a touch so gentle that sheets would lift away from the felt like they were floating on invisible strings. The sizing process came next, and this is where papermakers became alchemists, mixing potions that would determine how ink would behave on the finished product. Without proper sizing, ink would soak into paper like water into a sponge, creating blotchy, illegible writing that would make scribes want to throw their brushes across the room. The sizing mixture, usually a combination of alum and gelatin or starch, had to be applied in exactly the right concentration to create a surface that would hold ink cleanly. Different grades of paper required different sizing treatments. Paper destined for official government documents got the premium treatment, multiple coats of sizing applied with brushes made from the finest animal hair. Paper for everyday writing got a simpler treatment, but even the most basic sizing required careful attention to detail. The sizing had to penetrate just deep enough into the paper fibers to create a writing surface without making the paper stiff as a board. The final transformation happened on the drying walls. The drying walls were where wet sheets finally became real paper, and this stage was trickier than it looked. Workers would carefully brush each size sheet onto heated stone or plaster walls, smoothing out every wrinkle and air bubble with movements that looked more like painting than paper making. The walls were kept at exactly the right temperature, hot enough to dry the paper quickly, but not so hot that the sheets would crack or curl up like autumn leaves. Getting the brushing technique right took months of practice. Too much pressure and you'd tear the delicate wet paper. Too little and the sheet wouldn't stick to the wall properly, leading to uneven drying that would create papers with more wrinkles than a bloodhound's face. The best wall brushers could apply sheets so smoothly that the finished paper would be completely flat, without a single ridge or bump to interfere with writing. The drying process itself was like watching grass grow, except grass growing was actually exciting by comparison. Sheets had to dry slowly and evenly, which meant workers constantly monitored the temperature and humidity throughout the workshop. Too much heat and the paper would dry too fast, creating stress cracks. Too little and the sheets might develop mold before they dried completely. Some paper-making shops had workers whose only job was walking around checking the drying walls every hour, like ancient climate control technicians. What made this even more challenging was that different thicknesses of paper dried at different rates. The workshop had to coordinate the drying schedule so that thin sheets didn't over-dry, while thick sheets were still damp. It was like trying to bake cookies of different sizes in the same oven, except instead of slightly burnt cookies, you'd end up with expensive paper that was only good for lighting fires. Once the sheets were completely dry, they got peeled off the walls in a process that required the delicacy of a surgeon and the speed of a card dealer. Workers had to remove each sheet without tearing it, which meant finding exactly the right angle and pulling with just enough force to overcome the sizing that had bonded the paper to the wall. The sound of a sheet being properly peeled was distinctive, a soft whisper that meant success. The wrong sound usually meant starting over with a fresh sheet. The finishing process was where good paper became great paper. Armed with smooth stones polished to mirror-like surfaces, finishers would burnish each sheet until it developed the kind of smoothness that made ink flow like silk across the surface. This wasn't casual rubbing. It was systematic polishing that covered every square inch of the paper with overlapping strokes. The pressure had to be consistent, the speed controlled, and the pattern precise to avoid creating shiny spots that would make writing look uneven. Different stones created different finishes. River stones produced papers with subtle textures perfect for brush painting. Harder stones created mirror-smooth surfaces, ideal for detailed calligraphy. Some master finishers had collections of stones they'd been perfecting for decades, each one shaped and polished for specific types of paper. These tools were so valuable that they were often passed down through generations like family heirlooms. The trimming stage required precision that would make a surgeon jealous. Workers used incredibly sharp knives to cut away the rough edges left by the paper-making process, creating sheets with perfectly straight borders. The trimming had to be done in one smooth cut. Any hesitation would create ragged edges that would mark the paper as inferior quality. Master trimmers could cut through stacks of paper, with cuts so clean they looked machine-made. But trimming wasn't just about making neat edges. It was also about creating standardized sizes that scribes and government offices could rely on. Song Dynasty papermakers had developed a whole system of standard measurements, with different sizes designated for different purposes. Official documents required one size, personal letters another, and books yet another. Getting these measurements wrong meant producing paper that nobody wanted to buy. The sorting process was where papermakers separated the masterpieces from the mistakes. Each sheet got individually inspected under strong light, with sorters looking for flaws that would affect how the paper performed. Sheets with uneven thickness went into one pile. Papers with small holes or tears went into another. The perfect sheets, smooth, uniform, and flawless, earned the highest grades and commanded premium prices. The grading system was so sophisticated that experienced sorters could predict exactly how each sheet would perform with different types of ink and writing instruments. They'd run their fingers across the surface, hold sheets up to the light, and even smell the paper to detect any problems with the sizing or drying process. The best sorters could grade hundreds of sheets per day without missing defects that would cause problems for the eventual users. Now here's where the numbers get really impressive. A well-organized papermaking workshop could produce between 400 and 600 sheets per vat per day, depending on the size and thickness of the paper being made. The most common mold size for book pages measured about 12 by 18 inches, though government documents often required larger formats that could accommodate official seals and lengthy texts. The pressing process happened in two distinct stages that determined the final quality of the paper. The initial cold press removed most of the water and set the basic structure of the paper. This first pressing used relatively gentle pressure applied over several hours, allowing water to flow out slowly without damaging the fiber bonds. The second pressing, called the finish press, used much higher pressure applied for shorter periods to create the final density and smoothness. The fiber-to-water ratio in the vat was crucial to consistent production. Master papermakers maintained ratios of approximately 1 part beaten pulp to 20 parts water, though this varied depending on the desired thickness of the finished sheets. Too much fiber created papers that were thick but rough. Too little fiber produced sheets so thin they'd tear during normal use. Getting this balance right required experience that came from years of watching how different ratios behaved in the vat. The maintenance schedule that kept these workshops running smoothly was more complex than operating a modern factory. Vats needed thorough cleaning every 3 days to prevent buildup of old pulp that could contaminate new batches. The mesh screens in the molds required constant attention. Even tiny holes would create weak spots in the finished paper. Felts had to be washed and redressed weekly to maintain their water-absorbing properties. The sizing mixture needed fresh preparation every few days because the gelatin and starch would spoil in the warm workshop environment. Workers had to maintain precise records of which batches were prepared when, because using spoiled sizing would ruin entire sheets during the final stages of production. Some workshops employed specialists whose only job was preparing and maintaining the sizing solutions. But perhaps the most impressive aspect of this ancient industry was how it scaled up production without losing quality. Large workshops operated multiple vat lines simultaneously, with each line producing different grades of paper for different markets. The coordination required to keep all these processes running smoothly, from bark preparation through final sorting, rivaled anything modern manufacturing has achieved. The paper that emerged from these workshops wasn't just functional, it was beautiful. The smooth surfaces, even thickness, and consistent quality made it perfect for the artistic and literary achievements of Song Dynasty China. Government documents written on this paper have survived over 900 years in perfect condition, proving that these ancient craftsmen had mastered their art completely. What makes this story even more remarkable is that every technique, every tool, and every process refinement was developed through pure experimentation and observation. Without modern chemistry or engineering, these papermakers created production methods that remained largely unchanged for centuries. These ancient workshops operated with a precision that would make modern quality control managers weep with envy. Every single sheet that left the finishing tables had passed through at least 12 different inspection points, with workers trained to spot defects that were invisible to untrained eyes. The quality standards were so strict that sheets with flaws barely visible to the naked eye would get downgraded to cheaper categories or recycled back into pulp for the next batch. The recycling process itself was surprisingly sophisticated. Rejected sheets didn't just get thrown away. That would be like burning money in a society where paper was genuinely valuable. Instead, failed sheets would go back into the soaking pools, where they'd be broken down and turned into pulp for lower-grade papers. It was an early version of the circular economy, except these guys figured it out centuries before anyone invented the term sustainability. What really blows my mind about this whole operation is how they managed inventory and production planning. These workshops weren't just making paper randomly and hoping someone would buy it. They had regular customers, government offices, schools, wealthy merchants, and professional scribes who placed orders months in advance. The papermakers had to calculate exactly how much bark to process, how many vats to run, and how many workers to schedule based on orders that wouldn't be delivered for weeks. The seasonal planning was even more complex. Mulberry bark could only be harvested at certain times of the year, which meant workshops had to stockpile enough raw material to keep production running during the off-season. Some large operations maintained bark storage facilities that looked more like warehouses than craft workshops. The bark had to be kept at exactly the right moisture level. Too dry, and it would become brittle. Too wet, and it would rot before it could be processed. But here's where the story gets really fascinating. These paper-making workshops weren't just isolated craft operations. They were part of a massive supply chain that connected rural tree farms with urban markets hundreds of miles away. Bark merchants would travel established routes, buying from farmers and selling to paper makers. Paper traders would purchase finished sheets and distribute them to markets across the empire. It was essentially an early version of industrial logistics, complete with quality standards and delivery schedules. The transportation of finished paper was its own specialized skill. Paper had to be protected from moisture, kept flat to prevent wrinkles, and handled carefully to avoid damage. Paper merchants developed elaborate packing systems using bamboo containers and silk wrappings that would keep sheets perfect during long journeys. Some merchants became so skilled at paper transport that they could move thousands of sheets across hundreds of miles without losing a single sheet to damage. The economic impact of these workshops was staggering. A successful papermaking operation could employ 50 to 100 workers directly, plus dozens more in supporting roles: bark suppliers, tool makers, felt manufacturers, and stone polishers. The ripple effect spread through entire communities, creating prosperity that lasted for generations. Towns with good papermaking workshops became regional centers of commerce and culture. The social structure within these workshops was surprisingly democratic for its time. While master papermakers held the top positions, skilled workers could advance through the ranks based on ability rather than birth. A talented vatman could eventually become a workshop supervisor. An exceptional finisher might start their own operation. It was one of the few industries where social mobility was actually possible for common people. The training system was incredibly thorough. New apprentices would spend months just learning to prepare bark properly before they were allowed near the vats. Each stage of papermaking required different skills, and workers often specialized in just one or two areas their entire careers. The most skilled craftsmen, those who could handle every stage of production, were treated like industrial royalty and could command salaries that rivaled government officials. What made these workshops even more impressive was their ability to innovate while maintaining quality. New techniques would be tested on small batches before being adopted across the entire production line. Improvements in beating methods, sizing formulas, or drying techniques would spread from workshop to workshop through networks of traveling craftsmen. It was like having an ancient version of industrial research and development. The tool-making industry that supported papermaking was equally sophisticated. Molds had to be crafted with precision that would challenge modern woodworkers. The mesh screens required metalworking skills that produced incredibly uniform wire spacing. Even the mallets used for beating pulp were specialized tools, with different weights and shapes for different stages of the process. Some workshops employed full-time toolmakers who did nothing but maintain and improve the equipment. The quality testing methods these ancient papermakers developed would impress modern laboratories. They had standardized tests for fiber length, sheet thickness, ink absorption, and tear resistance. Master papermakers could predict exactly how a sheet would perform just by feeling its surface texture. They developed measurement systems so precise that sheets from the same batch would vary by less than the thickness of a human hair. But perhaps the most remarkable achievement of these Song Dynasty papermakers wasn't technical, it was cultural. They had created an industry that made literacy accessible to ordinary people for the first time in human history. Before cheap paper, writing was limited to the wealthy who could afford expensive materials. These workshops democratized knowledge by making writing affordable for merchants, students, and anyone else who wanted to preserve their thoughts on paper. So the next time you grab a piece of paper to jot down a grocery list or print out a document, remember that you're holding the end result of a 1,000-year journey that started with ancient Chinese craftsmen who figured out how to turn tree bark into the foundation of human knowledge. These papermakers didn't just create a product, they built the bridge between human thoughts and permanent record, making it possible for ideas to survive centuries and spread across continents. Without their wooden tools, plant-based chemistry, and incredible attention to detail, the world of books, documents, and written communication as we know it simply wouldn't exist.